Hey guys, welcome to another video. I am just noticing that this is the last new concept of this unit, and then we'll be reviewing for a test. Okay, so just have that in the back of your mind. What I want you to do is try these. Go ahead and mute me or whatever, not mute, pause me, and find f of g of 1. Find f of g of 3. Okay, given that those functions up there. And then also try to find f of g of x. Also find g of f of 6, g of f of -2, and g of f of x. Okay, so go ahead and pause me and come back and watch. Okay. All right, so you paused me, you did it. Let's see if you got them right. F of g of 1 means I put, and remember, another way of writing this is f of g of 1. But, there are two different ways of writing the same thing. This is this composition of functions. So I'm putting 1 in the g function. 1 cubed is 1. 1 minus 2 is -1. So I'm really taking f of -1. So I'm putting -1 in the f function. -1 plus 2 is +1. And the cubed root of +1 is +1. Okay, is that all right? F of g of 1 ended up being 1. Let's try f of g of 3. All right, so I'm going to do g of 3. 3 to the third power is 3 times 3 times 3. That's 27. 27 minus 2 is 25. So I'm going to do f of 25. So 25 plus 2 is 27. The cubed root of 27. In other words, what multiplied by itself as a factor 3 times is going to give me 27. That would be 3 times 3 times 3. So f of g of 3 equals 3. Let me pull up my calculator and make sure you know how to do the cubed root, okay? Okay, many people don't realize that, like, they see the square root. Hopefully you understand how to do the square root. You all downloaded this, I think, on your computers, your first week of school there. But that's the square root, okay? Square root of 81 means what times itself gives me 81. Of course, that's 9. Cubed root, guys, is under the word math. Okay, see the word math? We're going to hit math. And we're going to scroll down to, see cubed root, number 4. Cubed root of 27 is what we were trying to find out. That's what times what times what gives me 27, and that would be 3, because 3 times 3 times 3 is 27. Okay? Let's go the other way with g of f of 6. So I want to put 6 in the g, no, I'm sorry, 6 in the f function. When I do that, let's see, 6 plus 2 is 8. So I want the cubed root of 8. So let me go to math, scroll down to the cubed root, and say cubed root of 8. Let's see what we get there. Cubed root of 8, we get 2. Okay? So that means that I need to take g of 2. 2 in the g function, 2 cubed is 8. That's 2 times 2 times 2. Yep, 8 minus 2 is 6. F of -2, I'll put -2 in here. Oh, -2 plus 2 is 0. Cubed root of 0 is 0. So this is really asking me for g of 0. I'll put 0 in here. 0 minus 2 is -2. So here's what I want you to notice. F of g of 1, 1. F of g of 3, 3. G of f of 6, 6. G of f of -2, -2. These functions are called inverse functions, and that's what we're doing today. Inverse functions, they undo each other. Look, I'm cubing something and subtracting 2. Here I'm adding 2 and then cube rooting it. Isn't that cool? Let's see what happens when we do f of g of x. So that's going to be f of, I just keep scrolling up and down, sorry, g of x is x cubed minus 2. So I'm going to stick x cubed minus 2 into my f function right here. Okay, I'm going to use x cubed minus 2 for x right there. So that tells me to take the cubed root of x cubed minus 2 plus 2. Okay, instead of writing x, I wrote x cubed minus 2 right here. So it's x cubed minus 2 plus 2. All right, well, minus 2 plus 2, I'm pretty sure is 0. So I have the cubed root of x cubed root of x cubed, that's just x. When I do g of f of x, let's see, f of x was the cubed root of x plus 2. I'm going to put that in the g function, which tells me to take what's in parentheses, cube it, and subtract 2. So I'm going to take the cubed root of x plus 2. I'm going to cube that and subtract 2. If you cube a cube root, that undoes it. So I have x plus 2 minus 2. Again, I get x. These are some characteristics of these types of functions that we're doing. Okay. What we're doing are inverse functions. If you do the composition of them, you always get back to whatever was inside. F of g of 1 was 1. F of g of 3 was 3. F of g of x was x. Okay, they undo each other. Let's look at the graph of them, just for, just to see. Don't worry, I'm not going to be asking you to graph these by yourself. Okay, but I just need you to understand the characteristics of inverse functions. All right? So if I'm going to graph f, let's graph f in red. Guys, whenever you have a function that you're unfamiliar with, just stick numbers in, see what you get. Okay, I'm going to put, well, I'd like to put 0 in, but that gives me a cube root of 2, which I can't do. So I think I'm just going to put negative 2 in. Negative 2 plus 2 is 0. Cubed root of 0 is 0. Let's see, I know I can take the cubed root of what, like 1? So I wish I could think of something to put in here to give me 1, which that would be negative 1. Negative 1 plus 2 is 1. Cubed root of 1 is 1. I can also take the cubed root of negative 1, so let's put negative 3 in. Negative 3 plus 2 is negative 1. Cubed root of negative 1 is negative 1. I can take the cubed root of 8, so let's put 6 in, because then 6 plus 2 is 8. Cubed root of 8 is 2. Let's put negative 10 in. Negative 10 plus 2 is negative 8. Cubed root of negative 8 is negative 2. So that should give me enough points to plot. Negative 2, 0. Negative 1, negative 1. Oh, no, sorry. It's negative 1, 1. Negative 3, negative 1. Let me erase this blunder. What was it? 6, 2. So 1, 2, 3, 4, 5, 6, 2. It's right here. And negative 10. 1, 2, 3, 4, 5, 6, 7, 8. Negative 10, negative 2. Okay. It's sort of this thing happening. Let me pull down so you can see it. Okay. It's a nice looking curvy thing. X cubed minus 2. Let's do that one in blue. I'm going to put 0 in for x. 0 minus 2 is negative 2. Put 1 in for x. 1 cubed minus 2 is negative 1. Let's put negative 1 in for x. Negative 1 cubed is negative 1. Minus 2 is negative 3. We'll put 2 in for x. 2 cubed is 8. 8 minus 2 is 6. Let's put negative 2 in for x. Negative 2 cubed is negative 8. Minus 2 is negative 10. So I'm going to graph 0, negative 2. 1, negative 1. Negative 1, I'm going to have to go down here, huh? Negative 1, negative 3. 2, 6. down too far. 6, there's 2, 6, and negative 2, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we end up getting a curvy curve like so. Okay, now, isn't that kind of cool? Isn't that like symmetrical kind of thing happening? You see it? I'm sorry that you can't see the whole graph on the screen, but see that? Isn't that neat? Inverse functions are symmetrical about the line y equals x. If I would graph the line y equals x, in other words, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, the x and y coordinates always equal each other. If I graph the line y equals x, then inverse functions will always be symmetrical around them. Okay? It's another characteristic. Also, the domains and ranges are switched, if you notice. Here we have negative 2, 0. In g of x, we have 0, negative 2. Here we have negative 1, 1. In g of x, we have 1, negative 1. Here we have 3, negative 3. In g of x, we have negative 1, negative 3. Okay, the domain of f ends up being the range of g. And the domain of g ends up being the range of f. The domains and ranges are switched in inverse functions. Okay, here is the notation of an inverse. We use this little negative 1. People say f to the negative 1 power. No, no, no. It's not f to the negative 1 power. Okay? What it is f inverse. That's how you read this. This is the inverse of f. Now, instead of calling it f and g, now that I realize they're inverses, I call this one f and I call this f inverse. These are inverse functions. And when I see this, f of f inverse, I just already know that's going to be negative 2. That's what inverse functions do. F inverse of f, yeah, that's going to be 6. They undo each other, right? We saw that back here, okay? When it was called g. G of f of 6 was just 6. G of f of negative 2 was just negative 2. Okay? So now that we realize they're inverses, we just know that's what's going to happen. Okay? Because they're inverse functions. Here's some pictures of some inverse functions for you. X plus 3, the inverse is x minus 3. Again, notice they're always going to be symmetrical about the line y equals x. Here's the line y equals x, and it's symmetrical about it. 5 times x, x divided by 5. Those are inverses of each other. Here's x plus 3 over 2. Here's 2 times x minus 3. They're symmetrical about y equals x. If I would graph y equals x, those two graphs are symmetrical about it. Okay? And then down here, some ones that we're not going to get into these a lot. X squared, the inverse is square root of x. Now you do have to notice, I know x squared usually is a parabola, right? Like this. We're only using half of it because the square root of x, you can't have negatives under the square root. Okay, so you can't use the whole function if part of it doesn't belong in this domain. Cubes are not a problem. Isn't that cute? X cubed and cubed root of x. We did one similar to that. And then here's a fourth root. Again, with the fourth root, we had to restrict it to just greater than or equal to 0, which we'll talk about here in a minute. All right, so those are some inverse functions just to look at. Now, the only way we can find inverse functions is if my function is what we call 1-to-1. So that's what I was referencing with that. You saw how when it's when it's x squared, I couldn't really have an entire inverse, right? Because part of it wasn't in the domain. We'll finish this up in inverses part 2, if you'll go to that video. Thank you.